f of x equals x squared minus x cubed, perfectly good polynomial. That's our x squared polynomial minus our cubing polynomial, two of our fundamental functions. This can, of course, be factored to give us x squared times x minus 1. This polynomial then has zeros when x squared is 0, also when x minus 1 is 0, and no other place, because the only way this times this can be 0 is if this is 0 or this is 0. So x squared is 0, or x minus 1 is 0. X squared is 0 when x equals 0. X minus 1 is 0 when x equals 1. So the only zeros are here and here. In constructing this, okay, because at this point, when we conclude this, we didn't have the curve there. We just had this point and this point. Now we know from having constructed x squared minus x cubed graph using our fundamental points and so forth that the graph does look like this. How could we have concluded this from the zeros and from a little bit more information? Well, if the only zeros are here and here, the only place the function can change from positive to negative or negative to positive is going to be at one of these points. And of course that is what happens for this function. Okay? So these 2 points divide the axis into 1, 2, 3 intervals. I've color-coded those intervals here. On the interval from here to the left, from 0 to the left, the function is positive and getting huge as we move to the left. Because, of course, if x gets really big, we have the square of x, which is much bigger, and multiplied by x minus 1. Well, if x is really big, x minus 1 is still really big, right? And we conclude that if x is huge, this is really humongous. So as we go to the left, the function has to get really big. Now, either maybe big positive or big negative. Well, if we move to the left, x is negative, making x squared positive, of course, and x minus 1 is negative. So this graph is wrong. That's interesting. It's positive getting huge. It's actually negative getting huge here. Positive getting huge here, unless I'm looking at a different function. So I've written something down totally wrong here. Okay? And we maybe want to change this because, of course, this isn't what the graph looked like. What the graph looked like okay, yeah, the graph is, as I said, x squared minus x cubed. The only thing is that if we factor x squared out, we have a negative here. Okay, so, okay. So again, now if x is negative, this is going to be positive. The x minus 1 is going to be negative. So that's going to make this negative, but we have the negative out in front making this positive. Okay, so again, we divide the axis into 3 equal, not 3 equal, into 3 intervals. And on this interval, we argue from the fact that if x is a really big negative number, you get a humongous negative number, positive number out of this, that here x is positive and getting huge. So that's the way it looks. Okay? Now between here and here, between 0 and 1, well, we know from having graphed this that the function is positive, but if we didn't know, we could have evaluated the function for 1/2. Plugging in 1/2 for x, we get 1/8. And of course, having constructed this, we know that the value at 1/2 is 1/8. Now, there's nothing sacred about 1/2. We could have used any number between 0 and 1 to determine whether the function is positive or negative from here to here, because we can't cross the axis between here and here. So if it's positive anywhere between here and here, it's positive everywhere between here and here. Okay. Now, to the right of x equals 1, the function turns out to be negative and getting huge. Okay. Why is it negative? Because if x is positive, x squared is positive, so is x minus 1 as long as x is big. but we've got a negative in front of it. So we've got the negative of a positive times a positive. And if x is huge, we've got a really huge square and multiplied by a huge number here, giving us an extremely huge number, but negative. So x is negative and getting huge from here to here, and that's consistent with the way the graph appears to look here. So the process of graphing this thing, if we didn't already know what it looked like, we find the zeros, which divide the axis into intervals. There are 2 zeros, that divides the axis into 3 intervals. And on each interval, we test whether the function is positive or negative. And on the intervals that go toward negative infinity or positive infinity, we assume a huge number, a huge negative number here, huge positive number here, and we reason out what happens if x is a huge negative number. It's going to be a really huge positive number. If x is a huge positive number, it's going to be a really huge negative number, and we get this picture. And here are more details, more words that say the same thing that I've been saying, and there's a little more difference. I do include, well, we talk about a huge negative number. Well, what if x is negative 10? That's not all that huge. It's a negative number. Well, x squared minus x cubed, x squared would be 100. X cubed would be negative 1,000. Okay, x cubed is already a lot bigger than x squared because we're cubing 10 rather than squaring it. And of course we have the negative. If we do this, we get 1,100. So f of x is already 1,100 when x is just negative 10. Now that's a little bit off the board, but it's not all that far. But 1,100 is way the heck up there. Okay. Another thing, let's see. Anything else that I've written here that I think is worth pointing out? Not really. Okay. I do say on the interval from 1 to infinity, we assume x is really big, then x squared is really big, and x cubed is really bigger. Now that's just indicating that x cubed is a lot bigger than x squared if x is big. Okay. So on 1 infinity, f of x equals x squared minus x cubed is negative because what? The bigger number is being subtracted from the bigger number. Okay? So big minus really bigger is got to be negative. So right there it is. That's how we would analyze and graph this function. And having graphed this function by just making the table for x squared and x cubed and the graphs for x squared and x cubed and seeing how they work together, you can understand this even more deeply.